Welcome back to our channel. Today we are going to solve this problem number 12. Obtain the KVL equation for the given coupled coils. Here you can see here these coupled coils, these are the two coupled coils and currents are also given I1 and I2. So the current which flows in this branch is I1, the current which flows in this branch is I2. I1 and I2, when you apply the KCL, here the current is I1 plus I2 is the current. Okay. Now let's try to apply KVL for the loop 1. Apply Kirchhoff's voltage law for loop or mesh 1, or first loop or first mesh. Try to apply the KVL. So voltage source is equal to voltage drop. Voltage source is 5 at an angle of 45 degrees is the voltage source. Drop is I into R, okay, so which is nothing but I1 into 3, and here also it is the inductance I can write it as plus J4. So the formula for voltage V equal to I into R. You can write down resistance value into current value. The resistance value is plus J4 ohms into the current I1, okay, but this coil is connected with this coil with a mutual inductance of plus J3. So here current is entering the dot, here also current is entering the dot. When both the currents are entering, therefore we are going to get positive polarity and the mutual inductance value is J3 ohms and the current in this branch is I1 plus I2. Okay, so I can say that this is for coil 1. So this will act as self-inductance. This is also the self-inductance and this is the mutual inductance term plus. Now let's try to write down for this coil. Okay, so we had written for resistor and we had written for J4 and we had written for this coil, and coming to the original term which is nothing but J5 ohms into the total current is I1 plus I2. Okay, so that is how to write down. Okay, now let's try to write down for the second coil. So when you write down for the second coil, we are going to get okay plus J3 is nothing but the mutual inductance of. So here also current is entering, here also is current is entering, multiplied with I1. Okay, so I can call this as self-inductance and this as mutual inductance. Very simple. First one, resistance we can write down, and for the inductance we can write down it as J4 with the current of I1. But it has a mutual inductance value of J3 linked with I1 and I2. So with this self and mutual, up to it is completed. But coming to this coil, it has a self inductance of J5, I1 plus I2, and it has a mutual inductance of J3 multiplied with the current I1. Okay, so this is for loop 1. Okay, now let's try to write down for loop 2. Apply KVL for loop 2 or mesh 2. There is no voltage source, so it has only resistance, where I can write down it as minus J6 into the current is I2. The self-inductance of this coil. So here you can see here the self-inductance of this coil is plus J5 ohms with the current of I1 plus I2. The total entry current is I1 plus I2, J5 into I1 plus I2, and it has the mutual inductance. Here is also entering and here also it is entering. The current is entering the coil, therefore you are going to have mutual inductance value of plus J3 ohms. This has an inductance of J3 ohms and total current of I1. Okay, so that's how we are getting the KVL for the first loop. Okay, so first we write down self-inductance and then we complete the mutual inductance. And later we can write the self-inductance of this coil and mutual inductance of this coil. Mutual will always refer to the another coil. Mutual means inductance due to another coil. Okay, so this is self coil doesn't have mutual, but this has self. This is the self-inductance of the coil and this is the mutual inductance. This is the process of writing the KVL. If you feel my explanation is good, please like the video and share the video with your friends. And if you have any doubts, let me know in comment section. You can answer your doubt. And if you are watching my channel for the first time, subscribe to my channel with the name kvthulasi. Kindly support this sort of channel with your like and share. Why? Because this is a free channel for the development of students and faculty. Thank you for watching. We will meet with another beautiful video.